So this time I'm going to talk about, again, the crisscross method, but I'm going to use a little more complicated example. And what I'm going to use are what are called polyatomic ions. An example of a polyatomic ion is this, NH4 plus. Now you just got done drawing dot diagrams of NH4 plus. And what it is it's a nitrogen in the middle, 4 hydrogens covalently bonded. You end up with having one too many electrons, so it's going to give up an electron. This particular polyatomic ion, meaning many atom ions, is called ammonium. What I'm going to do is I'm going to bond it to another polyatomic ion, pH4 with a -3 charge. This particular polyatomic ion, which you drew pictures of, it had a phosphate in the middle, 4 oxygens off of it, needed 3 more to complete octets around everybody, was a tetrahedron. This is called a phosphate ion. Now initially you're going to have to use your chart of ionic names, cations and anions, to figure out what the names of these polyatomic ions are. Eventually some of the more common ones you'll get to know just because you've used them so many times. Now, how this works is I'm going to cross the charges. So there's the ammonium ion, and here is the phosphate ion, -3. Alright? So what I'm going to do is I'm going to take the positive charge from the cation and move it down into a subscript position off the anion. And then also take the charge of the anion and move it to a subscript position in front or next to the cation. When I do that, I have to be careful with this ammonium, because when I move the 3 down by the 4, I'm going to have to put in parentheses like this, NH4 parenthesis 3. The reason for that is that without those parentheses it would look like I had 43 hydrogens attached to a nitrogen, and you guys have messed around enough with drawing compounds that you know that that's probably improbable. So I need the parenthesis to say I need 3 ammonium ions, basically. And now I go to the phosphate, and I only needed 1 of those, because in moving down that positive charge, that's 1, it's understood. But now I've done that, I put those 2 together, the compound is neutral, which is the whole reason why they go together in the first place, and what I end up with is ammonium phosphate. And just like I said in the last video, the challenge of writing and predicting and figuring out what formulas and names are of ionic compounds is that the name has no reference, gives you no clue, no reference as to what the relative proportion of the ions is going to be. So that's the part that you have to go back and you got to figure out for yourself. All right?